In here, we got a question that says that what is the principal quantum number if the energy corresponding to that energy level is negative 328 kilojoules per mole? We have the following options, and you might be wondering, how do we begin in here? We got to begin by looking at specific keywords and knowing what they mean. Like, for example, principal quantum number. This here, when we underline it, it implies that we are looking at the first energy level, which you should know is represented as the number n ranging from 1 to positive values. And this here, which is known as the principal quantum number, can be shown visually when you look at the specific discrete energy levels. And when you have this here roughly that looks like this, we have each bar representing the energy level, and as you move from bottom to top, our n value increases, and this means that there is a relationship between it and another variable which is known as the energy. And the energy here is going to be what? Starting from 0 joules, or we just say kilojoules, which is same as that, but when we look at numbers wise, then we can say that 1000 joules is equal to 1 kilojoules, but we'll talk about that in details. But as you go down from 0, it actually shows that we are going at what? Increasing negative values. And what does this mean here? This means that we have our specific attraction to be shown between the proton and the what? Electron. And so what happens is that as you go down and you're approaching a n value to be equal to 1, we have the strongest a proton to electron attraction. But as you move higher and higher, we are getting to the point where our electron is slowly leaving the proton, and once you get to our 0 joules or 0 energy that is termed, this is where our electron leaves the particular or escapes the specific proton, or in general the atom. So looking at this foundation here, we're going to see how this corresponds to what? Something that we know from our quantum origin story, which comes from this interesting guy known as Bohr. And what did Bohr do? Bohr was able to bring the best of two worlds, where the first part focuses on what? Allowed angular momentum, and the other part here is bringing it with known as the energy of what? An electron. And bringing these two concepts here together, he was able to generate this formula, which is our energy is equal to what? The negative value of our RH, and this here is divided by what? The n squared. And so this here implies that we have quantized states, and each energy level has a specific energy, or in this case each quantum number has a specific energy associated with it. And this negative sign shows that there is a level of attraction between the proton and the electron. Now this RH represents the Rydberg constant, which is known to be experimentally obtained. And so once we have this here, we can now use specific values and introduce them into this formula as shown right here to determine what the n value is, as we established to be what? The principal quantum number associated with this specific energy. So bringing all those information together, we're given our energy to be equal to what? Negative 328 kilojoules per mole. And we have what else? We have our Rydberg constant, which is given to be this value 2.18 times 10 to the power of negative 18 joules per what? Electron. Now we have a couple of interesting conflicts here between these variables and their units. One is we have our kilojoules and joules, and we have our electron and our moles. So when we put this into our equation, this is how it looks like. But here, take note that we need to be able to change our unit from what? Joules to kilojoules, and to do that we multiply this here by what? 1 kilojoules, which is equal to what? 1000 joules. And so once we have this, we're able to eliminate our joules and keep our kilojoules as the numerator. But there's one more thing here, which is we want our number of electron, which in this case to go from electron to moles of electron. We can use our Avogadro's constant, and this shows that we are going to multiply this by 6.022 times 10 to the power of 23 what? Electrons, which is equal to or over, in this case, 1 mole. And since you have this, take note that this here is going to be multiplied by 1 over, based on this particular equation, n squared. And so once we have this, we have our results to be as follows. For this side alone, we have the value to be around -1312, but there are still more values, but we're just going to leave it as what? Kilojoules, 0.796 kilojoules per mole, and this is multiplied by 1 over n squared. Now once we have this, there are a couple of things that we can eliminate. As you notice here, we are going to eliminate our negative signs, they don't matter here, and we're going to do cross multiplication. And what that means is that our n is going to move to the other side as the numerator, and that results in our n squared, and this is equal to our, in this case, 1312.796 over our 328. And take note that our kilojoules per mole is going to be cancelling out our kilojoules per mole on this side as well, and that results in what? No unit at all. So that is perfect. Now once we have this, take note that because we have a squared at our n value, we are going to do the square root to undo it, and what that results in is this particular expression, and our expression will give us a value for n to be equal to what? 4.00 square root of 4.00, and this is equal to what? 2. And so what that means is that our n value, or our principal number 2, has the energy to be around -328 kilojoules per mole. And this here is how we're able to use the Bohr's equation, which is shown right here in our formula, to determine the energy of any n value, or in this case principal quantum number, in terms of determining how that is going to help us understand relationships between electron as it moves from one energy level to the next. So overall, I hope you found this really informative in terms of this particular question and determining what the value is, which is equal to 2. Let's know your thoughts about this in the comment section down below. If you think there are other interesting strategies that may help you to understand this concept better, please go down in the comment section and let me know your thoughts about this. All this way, stay smart as always and keep on practicing.